Thank you very much. Can everybody hear me?
Yes, loud and clear.
Okay. So my background is I started in EDA development for 23 years when I coming out of college, and I moved to embedded processors and TI back in 2021, where I became the Meta TI and Meta Rago layer maintainers. And I'm also in charge of the nightly builds as well as our CI/CD architecture for our core SDK, which is a Linux product that we do. There are other layers that we also maintain as a company. Those make up some of our more advanced products, but the core Linux product that we do is what I'm over. So TI is in the business of selling semiconductors. We like to sell chips. We don't really sell software. Everything we get comes from the chips. So the one thing that we want to do is we want to provide software packages so that customers that are choosing whether they want to go with our processors have a reference that they can go play around with to make a decision if our processors is better or which of our processors is good. Those SDKs that we provide on our website contain, pre-built images that you can flash onto an SD card and go ahead and load up and start playing with, documentation, as well as build scripts and some source code of things like the kernel and U-boot that you may want to make a modification to in order to play around with what you're doing. If you want to get into anything more advanced, though, that's where you have to go into some other type of a build system than something that we're going to provide for you. Of these SDKs that we do, we actually maintain a repository of all of the configurations of every version of those SDK tools that we have basically built and put up on the website. We also have our own layer setup tool that goes with it that we wrote years ago that goes along with this. But one of the things that we don't want to do is we don't want to be in the job of telling you how it is that you have to do your development by basically saying you have to use our layer setup tool. Many customers that want to do this will go off and use some other tools, and we're often the question of like, well, you're kind of on your own, or somebody has to hire somebody from like Consulta or something to come in and help them to get a flow set up on how to basically use Yocto to basically go off and build everything using our VSP layer. So I just want to do a quick background of what is a layer setup tool. I know they've been, several have been mentioned, but I don't know if anybody has sort of what a definition of what a layer setup tool should be. So there are several popular open source layer setup tools. I'm only going to talk about two right here, CAF and BitBake Setup, which is an upcoming tool from the Yocto project that will provide a, Yocto-centric, layer setup environment for what's going on. There are also vendor-specific layer setup tools, of which ours is an example. And the core features of a layer setup tool, they need to be able to download the repositories as well as choosing which branches and commits that you want to use of those repositories. They need to be able to create the directory structure that BitBake is going to go operate in. And they need to be able to populate in that directory structure a BB layers comp file for the layers that you've basically chosen to point to, as well as a local.comp for any initial default settings that you want to go off and do. There are secondary features that a layer setup tool might have. They might want to capture all of that configure information you have for what it is you're trying to capture into a single file so that you can share that config with others. Why would you want to do that? Maybe you want to debug it. Maybe you want to actually have a repeatable build so that produced a download of what you're doing for, like, for example, our SDK. If you want to go back and rebuild exactly what that SDK version was, you can grab one of our configs and you'll get all the versions of all the meta layers that went into it, as well as the version of BitBake. Or, you might want to use a layer setup tool with that single config file for nightly builds and for layer maintenance. Other features might be that you want to make it easy to sort of keep all the different layers that you have up to date, as well as being able to add and remove layers from there. I know BitBake has the add layers tool, as well as other interactions you can do, but sometimes also the config might make it easy just to quickly go in and add the repository that you want to have there. And also, how easy is it to develop that new layer and maintain an existing layer that you're wanting to do? Does the layer setup tool sort of make it easy to do that or not do that? So each layer setup tool tends to choose a different combination of features to focus on, which makes each different tool good at some tasks and maybe not so good at some other tasks. not a criticism of what they can do. It's just you choose to focus on something, and not everybody can, not everybody does everything extremely well. So from the TI perspective, which layer setup tool is the best? Which one do we want you to use? And remember, what we're trying to basically say is we have our software that we put out on our website. If you want to use it as a starting point, we'd like to be able to say, here's the configuration file that you can use to go up and do that one. So what we're kind of coming into now, after many years of doing this, we're kind of coming to the question of, well, why should we choose? Why do we need to basically choose a single layer setup tool? Why can't we support multiple layer setup tools? So what we'd like to do is start to maintain our configs in the config file formats for the different layer setup tools in our central repository. And how are we going to accomplish doing that? We're going to store all of the config information that we have in a common format. And we need that common format to be able to handle things like comments, so that you can easily comment, up the file. It needs to be able to support includes, so you can reference other files without having to basically have everything in one giant file, because as we're basically going through the different configs that we want to have, the different versions of it, they might include common components that we don't want to have repeated in every file. And so we chose XML as the format to basically do that. So the next step we need to have a way of transforming that XML into the different tools. And luckily, there is already existing technology that can do that. So we created templates so that we can transform the files using XSLT. And so the last piece remaining is we just need to be able to take the XML, run it with the template file through XSLT proc, and generate the various files that we have that we want to support with, the name of the file being the correct version that matches what the config you're trying to do. So what are the benefits of trying to go off and do the thing that we're trying to do? So if there are tool changes in these layer setup tools, if they add new features, or if there's new version updates that make changes to the config file format, rather than having to go through and hand edit every single one of the old configs, we can now just go through and edit the XSLT file and just regenerate the files. Because again, we have the core data in XML, and the XSLT allows us to now go off and just regenerate those other config files. This also allows us to say, if we want to add support for a new layer setup tool, there are other ones that exist out there. We've only focused on CAS, bitbake setup, and our current OE layer setup tool. But there are other methodologies that exist out there. And if somebody wanted us to support those, so long as there was good documentation on how to do that, to configure the file, we can easily go off and write an XSLT transform, add it to the make, and be able to then just generate all those configs. So that as a customer, if you're saying we'd like to go down this path, we can hopefully support you better in order to get into that using the versions that we know you should be using, but using the tool that you want to use. It also allows us to focus on, again, the configuration that we want to do, and not the specific syntax for a layer setup tool. So all of our internal tools that generate the configs off of our builds when we're ready to make a release, we instead just focus on generating the XML file, and we let the XSLT files and the make files actually do the generation for supporting all the other syntaxes. So here's just an example of one of the XML files that we have in there. You can see that we have the include reference using the XML include methodology for doing that. You can also see where we have the reference of what bitbake version to use and where to pull it from, as well as what repositories and what layers to include from which repository. We also have the ability, as I've said before, to lock into specific versions. So our most recent, or one of my most recent SDKs that we made was the 10 RC7 release. So this is the config file that we actually have for that. So you can see on here, we actually have the ability to, again, lock in the specific commit SHAs if we need to. So that version of bitbake is the one that we use to basically build this. So you can go back and recreate it exactly. Or we also have the ability to lock into tags. So since we tag all of our internal repositories with that same tag, we can also just include that tag in case, that's what we want to have in there. So in terms of wrapping up, if you want to see the example implementation of how we've done this in our OE layer setup tool, the URL for where our Git repository is right there. The source directory under that repository is what contains all of the XML configs as well as the XSLT transforms and the make file that you can use to go generate them. Future work that we need to do, I do need to do some improvements to our make file to extract out the dependencies of the includes, because right now, if I go and make a change to one of the includes that we have and run make, it doesn't pick up the fact that that changed. So I need to go do an include extraction step to automatically pull those out to not have to manually reference those inside of the make files. And then I also, once BitBake setup actually is finalized and has an initial version release, I will probably need to go tweak that implementation that we have on there to basically get that in place. So that's the future work, as well as adding other layer setup tools in the future if we need to. Are there any questions?
Ryan, thank you very much for your talk. It's always interesting to see how other people are dealing with multiple layer. Let's see if there are any comments in the chat.
One question is if you can generate Git submodules from that config.
If I can generate Git submodules, no. I mean, right now the config is just meant to generate the configs for other layer setup tools. So if those other layer setup tools have that capability, then yeah, you could use those configs to do that. But
Another question, how do you handle multiple hardware variants for BSPs?
so on the, use this new feature. So with the BSPs that we have, so MetaTI, our layer has the BSP in it. And so all it is just saying that this is the BSP layer that you want to, or not this is the BSP, but this is a layer and that is what provides the BSP from our builds. So whatever repository is that contains the BSP layer you're trying to do, you would just have a repository for that XML along with that layer reference for the BSP. And if you have any other questions, feel free to reach out to me after the conference.
Ryan, thank you very much again for this talk. It was very interesting, and I see a lot of people in the comments are cheering and saying that they love hardware with Texas Instruments. Also, a lot of people that are your ex-colleagues from Texas Instruments. So, thanks again for this great talk.
Yep.
And in a minute, we're gonna start with the next talk, which is by Joshua about unlocking S-bombs with the Yocto project and SPDX3.